So today we are going to be talking about recycling batteries. So what exactly is recycling batteries? Recycling batteries is the repurposing and reuse of old batteries through reprocessing. Recycling batteries is done to reduce the amount of material waste and has to be done because batteries contain poisonous chemicals that pose a threat to the environment. The recycling process begins with the sorting of the batteries into designated sacks or boxes, as there are specific purposes for the different types of batteries. For example, nickel-cadmium batteries are repurposed as the cadmium can be used to make new batteries or as a stiffener in materials such as cement. The cobalt used in lithium-ion batteries is used to create new lithium-based batteries. Lastly, the nickel and nickel-cadmium batteries and nickel metal hydride batteries are used in stainless steel products. The flammable material on the batteries, such as plastic, is removed using a gas-fired thermal oxidizer and used to make new batteries. Polluted particles produced during the burning are eliminated by a scrubber and released into the environment, cleaning the battery cells, which are then chopped into small pieces and heated until the metal is liquefied. Fun fact, Canada is 10th in recycling batteries. What are some benefits to society of recycling batteries? The first societal benefit of recycling batteries is associated with its eco-friendliness. Our growing use of batteries means that more raw materials are being mined, processed, and turned into new batteries, which are then turned into waste once they have been used. Recycling batteries reduces the need to collect new raw materials. This reduces pollution and greenhouse gas emissions that contribute to climate change. Furthermore, this conserves natural non-renewable materials such as metals and minerals, helping to sustain resources and the environment for future generations. In addition, the recycling of batteries reduces the amount of landfill created. Many of the metals in batteries are harmful to the environment and human health. For example, mercury is a cause of both historic and ongoing mercury poisoning, and lead and cadmium are both dangerous environmental pollutants. When disposed of in a landfill, batteries break down and the toxic materials leak out of landfills and contaminate groundwater and water bodies like the ocean. This may pose health concerns and threaten the ecosystem. Therefore, recycling batteries provides an eco-friendly solution and minimizes the negative environmental impacts of our use of batteries on the environment. Finally, through efforts in recycling batteries, awareness for environmental concerns will also be increased as people will better understand the risks associated with improper disposals of batteries and the importance of the conservation of non-renewable materials. What are some environmental and health concerns associated with recycling batteries? Firstly, one environmental concern associated with recycling batteries is that if the batteries are not handled with proper care during the recycling process, the toxic materials may be deposited incorrectly, which contributes to environmental pollution. Moreover, the high-temperature smelting process required for the breakdown of batteries for recycling is energy-intensive and might release toxic pollutants into the environment. For instance, fluorine is one toxin that is released and has to be treated effectively. Furthermore, fires have also been increasingly reported at battery recycling operation sites, such as lithium-ion batteries, were mixed into the process and exposed to excessive heat, causing a runaway thermal reaction. Additionally, shipping recycled materials from one manufacturer to another might be dangerous and hazardous if the flammable materials are not handled carefully. Majority of the hazardous waste is exported from developed countries into developing countries for recycling. Since there are lower health, safety, and environmental standards in developing countries, informal operations of lead-acid battery operations are estimated to be one of the largest sources of chemical pollution for less developed countries, and some reports even cite the prevalence of child labor and unsafe working conditions in lead-acid battery operations, specifically in China, Bangladesh, and India. Two practical examples of recycling batteries are the recycling of lead acid and alkaline batteries. Due to their abilities to produce large volumes of current, lead acid batteries are generally used as car batteries or in emergency lighting. When their battery life ends, they are ground up and destroyed. A neutralization reaction then occurs in the recycling process to neutralize the acid in the batteries. The materials produced are then repurposed. The sodium sulfate is used in laundry detergents, and the metals are used in other products, or even recreated to make new batteries. On the other hand, alkaline batteries are mainly used in many household items, such as toys, flashlights, radios, CD players, and remotes. After their battery life ends, a mechanical separation occurs to separate the materials into three components: zinc and manganese concentrate, steel and paper, plastic and brass. These materials are then recycled and reused to make new products. So how does recycling batteries relate to electrochemistry? Consisting of one or more electrochemical cells, batteries largely operate through redox reactions. Batteries comprise of cathodes, which connect to the positive end of the battery, and anodes, which connect to the negative end of the battery. Since the cathode accepts electrons and the anode loses electrons, the cathode is the oxidizing agent and the anode is the reducing agent. For example, several redox reactions take place in lead-acid batteries. Oxidation occurs when the current flows from the inside, as shown by this half reaction of a redox reaction. There is a loss of 2 electrons. Reduction occurs when the current flows from the outside, as shown by this half reaction, and there is a gain of 2 electrons. This gives the overall reaction with a voltage of 2 volts. When the components of lead-acid batteries are separated, lead oxide remains, which undergoes a redox reaction to form lead again. The lead is then melted to create more batteries. Thank you.